Hi everyone. In this video I'm going to talk about Model View Controller with a particular emphasis on how this design pattern is applied to Java applications. So what is Model View Controller? Well, at a high level, it's a design pattern for programs with a user interface. Now, of course, some of you are probably wondering, what is a design pattern? Well, in general, a design pattern is a pattern we use when writing a program. And that can be, as in the case of Model View Controller, a pattern for laying out how our code is organized, where we put different parts of our application. Another way to look at that is a convention of where to put certain types of code. Now, we do this because by following these conventions and these patterns, it makes the code easier to understand and maintain. I'll come back and explain this a little bit more after we see what the design pattern looks like. Now, a couple of things to keep in mind as we go through this. First of all, Model View Controller applies to much more than Java. I'm going to be talking about it with a focus on a Java application because that's what we're doing in the classroom. But keep in mind that this isn't just about Java. This is something you will see in just about any programming job you take, especially if you're working in the world of web development. A lot of web frameworks are based on the Model View Controller design pattern. So the basic idea when you're building an app using MVC design is that the code in your application gets divided into three buckets: the model, the view, and the controller. The view is where all of your UI-related code goes. So in the case of building a GUI app in Java, anything with the Java swing, the JFrame, the JPanel, the buttons, the text fields, the labels, any of that stuff goes in the view. And the job of the view is to draw a picture of the current state of the model or the state of the application. I'll come back to this when we talk about the model a little bit more. Now, a couple things to keep in mind. The view should not maintain any state. Its only job is to show you a picture of what's going on. Anything you have to remember should be remembered by the model. And the view shouldn't modify the model or talk directly to the model. Now, the model is where all of your application logic goes. So if you're building a game, then that means your game state, like who's playing, the number of points, whose turn it is, anything that you remember when you play a game should go in the model. And as a point of contrast, as I said a minute ago, it should not go in the view. So the view may display whose turn it is, but it's not the job of the view to remember whose turn it is. So guard against that. It's also the job of the model to apply and enforce the rules. So it's the model that decides whose turn it is. It's the model that decides if a particular move is within the rules or not. The other big place that you see MVC is in the world of web applications. So just to give you a better idea of what that looks like, things like your database accesses go in the model, or any sort of business logic. Who's entitled to a discount? Who's entitled to log in? Who has permission to be in this part of the site? Any of that sort of logic or state of the business application goes in the model. And then it's the job of the controller to connect the model and the view together. It's also the job of the controller to respond to UI events. So when you interact with a GUI by typing things into a text field or clicking a button or hitting a submit button or something like that, the UI framework generates messages, and those messages go to the controller. And then when the controller gets those messages, it's its job to translate those messages into methods to be called on the model. So for example, if you have a game where you're rolling dice and you click the button to roll the dice, then your UI framework tells the controller, hey, the roll dice button was clicked, and it's the controller that knows which method on the model to call to actually make the dice roll. After those methods run, whatever they are, those methods typically update the model state in some way. They roll the dice, they change the turn, they move a token on the board, something like that. Once all that is done, then the controller turns to the view and says, update the view. Change what the user sees to reflect what just happened to the model. Now, just like with the view, The controller should not maintain any state. If you're playing a game, the controller shouldn't be remembering whose turn it is or anything like that. That belongs in the model. Likewise, the controller shouldn't implement any application logic. We'll see some examples of that in just a minute. All right, so to help pin this down a little bit better, I'm going to go through some of these points again with respect to a specific Java application. So this is a game. The details of the game aren't terribly important, but it's a dice game. What we have here are 6 dice, 2 white dice, and a red, yellow, green, and blue dice. And then we have some numbers up here that we're going to cross off based on the rolls of the dice, and down here are the scores. So for example, here we have a roll button. So I'll roll the dice, and I see that I have a 4 and a 5 in white. So I'm allowed to check off 4 and 5 are 9, so I can check off any 9 I want. So I'll check this 9 off. So I can now match up one white die with one colored die. So for example, I could choose a red 11 or a yellow 6 or something like that. I'll choose a yellow 6, and then I'll roll the dice again. And as I cross things off, I get some points. There are, of course, more details to this particular game, but they're not highly relevant to this example. But let's see how this little game gets divided into model and view and controller. So we'll start with the view. The view is what generates this picture here. The boxes with the numbers in them, and the dice, and the scores, and the buttons, and all of that. So if you've done Java GUI programming before, some of this will look familiar. What is our view? Our view is primarily a class, and inside of this class we have the J-frame, and we have some buttons, those 3 buttons you saw, and we have an array of labels, those are the numbers, and we have some more labels that are the dice and the score and so on. So all of those UI components, the different things that we organize, that we look at and interact with, they all belong in the view. And so there's the code here that creates the buttons, and it puts them in the J panels, and it organizes them just right so it looks good. The other thing that's in the view is an update method. You don't have to call it update, that's just what I called it. And the job of the update method is to update the view based on the change in the model. So like when I roll the dice, then at some point I have to come back in and make these numbers change to reflect that the dice were rolled. So this is what we see here, is we go through an array and we ask the model what are the values on the dice, and then we update the labels. We just change what's printed. Now to reinforce what I said earlier, notice that the view is not in charge of remembering what's on the dice. The model is in charge of remembering what the values of the dice are. All the view does is display that number. As you're designing a model view controller type project, resist the urge to let your view be the source of truth. A common mistake I see among novice programmers, especially programmers new to designing GUI applications in Java, is they look at this and they see that the J labels or J buttons or whatever these are hold the current values of the dice, and so they use that as a source of truth. When they want to know what's on the green die, instead of asking the model what the current value of the green die is, they go over to the view and try to get the label text of the particular J label, and that's the wrong way to do it. All the view does, the view is very dumb, all it does is draw a nice pretty picture of the current state of the game. Next we want to look at the model. The model is where all of the game logic goes, and game state. So for example, inside of the model, that's where we have some data that keep track of what's on the dice. We have a data that keeps track of which numbers we've used. We have a data that's keeping track of the score. Anything that you want to remember as you play the game goes here in the model. This is your source of truth. And this is also where you implement the rules. So when it comes to rolling the dice, there should be a method that rolls the dice. When it comes time to roll the dice, call this method. When the user wants to check off a box or cross off a box, you should have a method to do that. And this is the method that decides whether you're allowed to cross that box off. It's also the method that would change the score based on what was crossed off, and so on. That all goes in the model. And it's the controller that ties it all together. So remember I said your event listeners go here in the controller. Now that's probably a little different from what you might have done in your first computer science class if you've done some GUI programming before. So later we'll talk about the mechanics of how we can put event listeners in the controller. But for now, just realize that's where your event listener goes. When somebody clicks a button or hits enter or something like that, you want to start running some code inside of your controller. Your controller is the brains of the operation or the traffic director, or however you want to look at it. So when you click that button that says roll the dice, then some code here in the controller should run. It's the controller that knows that when the UI says the user clicked the roll dice button, that the method on the model is called roll dice. So it turns to the model and says roll the dice. The model generates the random numbers or whatever that makes the dice roll. And when that's done, then it's the job of the controller to turn to the view and say the model state has changed, update your picture. And that's what we saw before where we went through this loop. Just like the view, the controller should also not have any state or application logic in it. So let's go back to the game. We're going to finish out this turn here. So I'm going to select a 5 and then how about a 2 of blue. Now notice I'm supposed to roll the dice now. I've made my selection from the white dice and the colored dice. But let's say I try to select something else anyway. I get this error that says you must roll before selecting a number box. Right? So that's the rule. The rule is after you've selected twice, you have to roll again. And let me show you how that happens here, because it's tempting to let that piece of logic sneak into the controller. So here's the controller. Here is the listener for clicking on those number boxes. And so one of the things we have to figure out is, well, are we even allowed to select a number box? Notice how that's handled here. If we look down on line 62, is we turn to the model and say, hey, are we allowed to select a number box? And that's the right way to do it. You make sure the model is the one making that decision. Sometimes it's tempting, especially as a novice programmer, to let that logic sneak into the controller, and you might say something like if model dot two numbers selected or something like that. But you want to make sure that the only thing you're doing is having the model answer a yes or no question for you. The other thing you might be tempted to do right in the controller is pop up that modal dialog box, right? What happens when we tried to select a number is this dialog box popped up and said, hey, you can't do that. You got to roll the dice. Because that's a user interface thing, we need to make sure that that happens entirely in the view. So here I have a method called display error that makes that box pop up. If we look in the view at display error, we can see that it's just a static method called jOptionPane.showMessage dialog. Again, it might be really tempting to just put the call to show message dialog right in the controller. But that's not the job of the controller. Showing dialog boxes is a user interface function, so you do want to push that into the user interface. Now, the job of the controller is to separate the model and view. We'll talk a little bit about why that is in a minute. In theory, the view shouldn't talk to the model at all. Everything should go through the controller. Well, as a practical matter, we fudge a little bit just to make the code a little easier to deal with. You'll notice that the view is talking to the model to say, hey, what are the dice values? So the important thing here is the view should not be changing the state of the model. The view shouldn't be giving any directions to the model like roll the dice or give player 1 more points or something like that. The only thing the view should be doing is asking the model about its state. And that's what we see here. The view is just asking the model for the dice values. It's just a query. And then it's updating the labels accordingly. And then it asks for what are the current values of those number boxes up top. And then it asks for what the current score is, and so on. These are all questions. None of those model methods that we're calling are methods that will change the state of the model. So you have to have a little bit of discipline to do that. It's easy to cheat a little bit when you think it might be easier, but resist that temptation. Set those habits early so that you end up with good design. In this video, we looked at the basic layout of the model view controller design pattern and also looked at how we could apply that pattern to a simple GUI Java game. The beginning of the video also gave some benefits of the model view controller pattern at a very high level. The next video will take a closer look at those benefits.